Today we solve different numerical formula based on column and strut. Yeah. The first question, read a hollow alloy tube 5 meter long. Yeah. Length equal to 5 meter with diameter 40 millimeter. Hollow, that means this is outer dia. This is 40 millimeter and 25 millimeter. That means this is inner dia. This is 25 millimeter. Was found to extend. That means this is deformation. And from stress system chapter we know this is del L. That means it may be extension or shortening. Here this is extension. This is 6.4 millimeter. Under a tensile load F, this is equal to 6 ton. That means 6,000 kg. 1 ton, this is equal to 1000 kg. Find the buckling load. P suffix equal to question mark for the tube when used as a strut with both the ends pinned. Remind, both ends pinned. Pinned means hinged. Yeah, as both ends hinged, we know that equivalent length, this is equal to actual length, and this is equal to 5 meter, and this is 500 centimeter. When load is in kg, then all the dimension you may be taken centimeter. Yeah, and so this is 500 centimeter, this is 4 centimeter, this is 2.5 centimeter, and this is 0.64 centimeter. This is the first given, from where you have to find out crippling load. And we know that here crippling load, this is equal to pi square EI by L square. Yeah. So the formula is this, and here capital E isn't given. So what is the relation between Young modulus and the given condition? Look at, this is the relation between del L and E. We know that from stress system chapter, del L equal to PL by AE. Yeah, here show capital E, this is equal to PL by del L into A. Yeah, and here also A equal to pi by 4 capital D square minus small d square. Yeah, and this is pi by 4 capital D, this is 4 square, small d, this is 2.5 square, and here the value is 7.66. This is centimeter square. And if you put here the value P for here P means, remind it, here P means force F. Yeah, this is 6,000. Yeah, L for 500 by del L, that is 0.64, and A for 7.66, and this value will be 611.9 into 10 to the power 13, and here the unit kg per centimeter square. This is the value of capital E, and if you put this value here, this will be pi square E for 611.9 into 10 to the power 3, and I also required, yeah, remind, I also required here I equal to, for hollow circular section, this is pi by 64, capital D to the power 4 minus small d to the power 4. Yeah, and here pi by 64, capital D means 4 to the power 4, small d means 2.5 to the power 4. Yeah, and this value will be 10.65 centimeter to the power 4. And here the value, this is 10.65 by capital L, here this is 500 square, and this value will be 257.3. This is the first answer. Yeah, and now the second question. Read, also find the safe load. The second, also find the safe load when factor of safety force, this is 4. Yeah, and we know that safe load, this is equal to buckling load. Buckling load divided by force, and here the value buckling load 257.3, and factor of safety, this is 4. Yeah, and this value will be 64.3 kg. This is another answer. Yeah, this is the first question. Yeah, and now you read the second question. Read the second question. Look, an I section joint 40 centimeter into 20 centimeter into 2 centimeter. This is I section. Look, this is I section. centimeter, the large dimension you shoot the height. 20 centimeter, this is 20, and 2 centimeter, and this is 2. This is 2. This is uniform. Yeah, this is 2. Yeah, this is I section. Both end fixed. Remind, both end fixed. Both ends fixed. That means capital L equal to small l by 2. We know that. And here the length 6 meter. 6 meter by 2. And here all the dimension centimeter. So this is 600 by 2. That means 300 centimeter capital L, equivalent length. Yeah. And capital E, Young modulus here 2 into 10 to the power 6. This is kg per centimeter square. What is the buckling load? And we know that buckling load, this is equal to pi square EI by L square, and here L is given, capital E is given, so this is moment of inertia I. You have to find out for this I section. Okay, so remind the chapter moment of inertia. Yeah, first you have to calculate moment of inertia. So this is y-axis, this is x-axis, and here the value, this is y bar. And as this section is symmetrical about y axis, so x bar equal to 0. Remind x bar equal to 0. So at first we have to find y bar, and we know that y bar, that is a1 y1, a2 y2, a3 y3 by a1 plus a2 plus a3. Yeah. Now put the value a1 for, so split up the whole section. This is 1, this is 2, and this is 3 section. Yeah. For section 1 area 20 into 2, that means this is 40 into y1, and as you calculate y bar, you have to take the axis of reference, the bottom line of the whole section. That means this is AB, and you have to calculate all the calculation from AB. Yeah. So y1, that means the CG of one section from AB. So from AB, first of all, this is 2, and this is 2 and 2, that means this is 36 here. So this is 2 plus 36 plus this point, that means this is 1, 2, 36, 1, that means this is 39. Yeah, that means y1, this is 39, plus a2 for section 2, this is 36 into 2, that means 72, into y2, that means 2 plus 36 by 2, that means 20, plus a3 for 3 section, this is 20, this is 20 into 2, that means 40, into y3, that means the CG from AB, that means here this is 1 to 1, by a1 plus a2 plus a3. Yeah, and you calculate this value, and this will be 20 centimeter. Yeah. Now you have to calculate IXX1, IXX2 and IXX3. Yeah. So y bar is equal to 20 centimeter. Remind, y bar equal to 20 centimeter. Now you have to find out IXX1. Yeah, and we know that the formula IG1 A1 H1 square. Yeah, so IG1, that means this is B1 D1 Q by 12 plus A1 H1 square. Yeah, and for section 1 B1, that means this is 20, D1, that means 2 Q by 12, plus area, that means this is 40, and remind it H1 means y bar and y1, this is the difference. Yeah, and we know that y bar is 20 and y1 this is 39. So here this is 39 minus 20 the whole square, and you must calculate this value, and this is centimeter to the power 4. Yeah. Similarly, we have to calculate IXX2, and the equation, this is B2 D2Q by 12 plus A2 H2 square, and here the breadth for 2 section, this is 2 D2, this is 36 Q by 12 plus area 36 into 2, that means 72, H2, that means here y bar and y2, y bar 20 and y2 this is also 20, that means here 20 minus 20 the whole square, that means this portion is neglected. Yeah, so you must calculate this value, and this is centimeter to the power 4. Similarly, I have to calculate Ixs3, and this is B3 D3Q by 12 plus A3 H3 square. Yeah, and B3 for 3 section, this is 20, D3 that means this is 2 Q by 12, A3 that means 20 into 2, this is 40, and H3 this is Y bar and Y3, the difference. Y bar this is 20 and Y3 this is 1, the whole square, and you must calculate this value. Yeah, in this way we have to calculate Ixs1, Ixs2, Ixs3. Now Ixx for whole section. For whole section, this is Ixx1, Ixx2 and Ixx3, the summation, and this answer will be 3682 point something. This is centimeter to the power 4. Yeah, in this way you have to calculate Ixx. In brief, you can calculate Ixx in this form. Remind it, if you imagine this is the block, that means this is the rectangular section. Here Ixx can be calculated easily. Here the rectangle form, this is the breadth 20 and this is the height 40. That means BDQ by 12, that means 2 into 40Q by 12. But you must deduct this section, and here the breadth, this is 20 minus 2, that means 18, and the height, this is 36Q by 12, and here also the value will be this. Yeah, this centimeter to the 4. And here in column and start, you must have to also I suffix YY. Yeah, I suffix YY. I suffix YY, and this is dBq by 12. Here, this is dBq by 12 plus AH square. But here, H means X bar and X1, the difference. But here, X bar is 0. So, this portion can be neglected. So here the form just dBq by 12. So for one section, this D 2B 20Q by 12 plus, for two section, this is 2 into 36 dBq by 12. Yeah, dBq by 12. So D means 36 into B means 2Q by 12 plus, for third section, D that means 2, B that means 20Q by 12, and you calculate this value. Yeah, here the answer 1357.3 centimeter to the power 4. You calculate, it may be wrong, you must calculate. Yeah, so this is Iyy, and look at here Iyy less than Ixx. As Iyy, moment of inertia about y axis is less than moment of inertia about x axis, so the column will be buckled in y direction. Yeah, so the value here I equal to Iyy equal to 1357.3. Yeah, now you calculate I in this way. Now the buckling load. Now the buckling load, P suffix C, this is pi square EI by L square, and here the value pi square, E means 2 into 10 to the power 6, I means Iyy, here the value 1357.3 by L, L for here 600 square, and the answer will be 297.7 into 10 to the power 3 kg. That means 297.7 ton, and this is the answer. Yeah, you calculate seriously, and this answer may be wrong, but the process is this. Yeah, and this is the second question. And the third question for T section, 15 centimeter into 12 centimeter into 2 centimeter T section. Remind it, if you erase this portion, this will be T section. Yeah, here the dimension 15 centimeter. Remind it, here the 15 centimeter, not height, may be taken in this form, 15 centimeter. 12 centimeter, here this is 12 centimeter, and another is 2 centimeter, this is 2 centimeter. Yeah, this is actually the T section. And similarly, you calculate y bar, I xx, I yy, and here the answer I y bar, this is 3.4 centimeter, I suffix xx, this is 608.7, I yy, this is 569.2 centimeter to the power 4. Yeah, and here also I suffix yy less than I suffix xx. So you take the value I means here I suffix yy. And similarly, crippling load, this is pi square ei by L square. Here capital L, remind, both end hinge, that means capital L equal to small l. And here the value L, this is 4 meter, that means 400 centimeter, and the answer will be 70.2 ton. You must calculate. Yeah. On the next day, we also solved another 2 problem based on Rankine formula. Yeah. So thank you.